Whoops.
Yes, should I introduce Pattie? I'd like to introduce Pattie Maes, my colleague at the Media Lab. She's a professor and former department head for media arts and sciences at MIT. She heads the Fluid Interfaces group my group works very closely with. They're really at the frontier of how we connect to computers in different ways. She's the co-founder of some great MIT spinoffs, including Firefly Networks, that essentially responsible for all the recommendations you see on Amazon and everything. She was the person that started that. She made Rod Brooks's Robots Walk as a student with subsumption and all this. Wonderful career at MIT. Let's hear what she's doing now.
Thank you. Hi, good afternoon. It's really an honor to be part of such an amazing panel. Thank you to the Xapiens people for organizing this amazing lineup. Okay, well, if we look at this lineup, I think we all kind of have the same goal in common, and that is that for a baby, whether they're born now, in 10 years, 100 years, 1,000 years from now, we want to maximize their potential, sort of. We want to let them live the best life that they can live. But all of us use a different toolbox. If you take someone like David Sinclair, you'll hear from him later, but I believe his toolbox is more one of drugs and chemicals that can maybe let us live sort of better lives, better quality lives, and that can let us live longer and counter the effects of aging, etc. If you take someone like George Church, he's of course working on, or his toolbox is the biological one, specifically gene editing to maybe alter the future of this baby, alter their environment, alter their offspring, and so on. And my toolbox is the digital one. My background is in AI and human-computer interaction, and I studied AI because, like Steve Jobs, maybe, I saw computers as a means to help people, as a means to empower people. He came up with this famous quote that they are the equivalent of a bicycle for the mind, because they're letting us do things that otherwise wouldn't be possible. But if you think about sort of where we're at with computer technology, I would argue that we're still sort of on the left, if you continue this analogy with bicycles, rather than sort of the super fast, completely integrated hybrid system of the rider and the bicycle. The person on the left there doesn't look all that confident that he isn't about to fall over, and just like today's cell phones and computers, probably that bike is demanding his complete attention rather than letting him just go with the flow and go where he wants to go. So if we look at today's computers and smartphones specifically, of course, they have put the world's information at our fingertips, which is marvelous. However, I would argue that they do not help us with a range of cognitive functions that are possibly even much more important in life for your life to be a successful life. Things like the ability to be attentive, motivation, grit, making mindful decisions, being able to change bad habits that you may have, having a great memory and increased learning speed, being able to be creative, regulating your emotions so that they don't interfere with success in life. These are all things that today's computers actually have a negative impact on, I would argue, rather than a positive impact. And these are exactly the things that I'm interested in helping people with. So my work at the lab, at the Media Lab, has been focused on how we can create minimally disruptive devices that actually help people with optimal functioning and with some of these cognitive skills like attention, etc., that are really important. Oops. So our process is one where we start with some insights from neuroscience or psychology, and those typically inspire some kind of system that can help individuals with a cognitive skill. But then that system that we built often enables, or typically enables, new opportunities to understand people's cognition, to understand people's mental behavior, and that can then result again in new insights in psychology and neuroscience. If you look at the domains of psychology and neuroscience, primarily most of the research is happening still today in lab settings, and we are very interested in my lab in moving that to the real world. We have the opportunity now with wearable devices that all of you, I'm sure, have with you today, to basically not just collect data about your behavior and understand more about what is normal in terms of attention span, etc. But also we can start using these devices to intervene and to help you in the moment, since that device is with you right now. And I'll give you some examples of how we do that. So all of the work that I'll be talking about is our projects that we are doing today in my lab. Take supporting attention. 10% of kids in the US are diagnosed as having ADD, ADHD. Of course, all of us have attention problems, especially today, given the bombardment of information that we're subject to. So we have been thinking about how we could actually build devices that give you biofeedback about your attention level. Could we actually teach people or train people what it means to be attentive, and could we teach people to be more attentive simply by giving them biofeedback rather than giving them Adderall or Ritalin, which stunts their growth and affects their sleep, etc. So one project in a group by my postdoc Natalia is a system that uses an EEG headband, and we have another form factor as well. And it basically detects your brainwave activity in the moment, for example, here and now while you're listening to a lecture, and then gives you haptic feedback through sort of two motors in the scarf whenever your attention level is low. We have done tests so far with 60 subjects over multiple sessions, where we actually had people sit in a classroom and listen to a lecture. A third of the group had a biofeedback and was like tapped on the shoulder, so to speak, when they were not attentive. A third of the group got random feedback, haptic feedback, and a third of the group got no feedback at all. And so this is what the data from one person, say, looks like, typical person in the feedback condition, where their attention level varies over time. And then if it's below a certain threshold, we give them the haptic feedback and their attention improves. And what we did is we looked at both self-reported attention level of these three different groups, as well as attention as measured by the device, the EEG device. And the biofeedback group in yellow actually has a much higher average attention level than the other groups, the random group. Random feedback helps a little bit as well, or the no feedback group in red. We also gave people quizzes, tests about the material that they learned in the lectures, and I apologize that I wasn't consistent with the colors, but in blue is the biofeedback group, and the people who received the biofeedback to keep bringing their attention back to the speaker did a lot better, significantly better than the two other groups in answering questions about the lectures. We now have just accepted for another conference the new form factor of this device, which is actually in the form of glasses with built-in EOG for measuring eye movements, as well as EEG for measuring brain activity. And the feedback is separate, actually, in the form of something that you can clip wherever you want on your clothing to get a haptic feedback. So this is an example of the kinds of systems that we built. Given that we now have technology with us all the time, an internet connection, etc., we can start collecting real-time data about people not just about their external context, but about their internal context. What are their eyes doing? What is their brain doing? What are their physiological data? We can even collect potentially video and audio, etc., and then use that for real-time interventions that can help the person with optimal functioning. And what is really interesting is that the devices, these devices can actually optimize their functioning, because when the device gives you an intervention, for example, haptic feedback, it can then see whether that made an effect or not and whether your attention level increases. And if it doesn't, maybe next time it gives you a different type of feedback, etc., because it can optimize its functioning for one individual. Some other things we're working on. This project is one where we wanted, again, to integrate the person and the computer more closely. And so we built a device that basically reads signals from your speech muscles and speech area so that you can silently talk to a computer. And maybe I'll show the next video, actually.
What is 45,689 divided by 67?
Sure.
He silently asks the computer and then hears the answer through vibrations transmitted through his skull and into his inner ear.
6, 8, 1.9, 2, 5.
Exactly right.
One more. What's the largest city in Bulgaria, and what is the population?
The screen shows how long it takes the computer to read the words that he's saying to himself.
Sofia, 1.21 million.
That is correct.
So basically, we pick up this video is by now about a year old. We actually have a newer version of the system that is a lot less visible, and we have fewer electrodes actually just in these two areas. We personalize basically, or do a personalized training based on the data that we get from one person, where they will teach the system to read the signals that correspond to particular words. And in our experiments, and this is a result that was published in IUI in 2018, we get about 92% accuracy rates. We've also been doing a lot of work, not quite this, like you see in the picture, although maybe Ed Boyden will talk about this, but we do a lot of work on supporting memory and learning. And again, taking certain principles and knowledge from psychology, from neuroscience, we develop totally new types of systems that can help people with a particular skill, in this case, memorization. So people have known that we have different types of memory: factual memory, episodic memory. And it turns out that episodic memory is actually sort of a lot stronger, and it's easier to recall things if they are connected to experiences, to a place, etc. So what we did is we built a system. It uses these augmented reality glasses that teaches people some facts by making it more into an experience. So we actually tested this with the different winners of the Super Bowl, and a person wears the augmented reality glasses as they follow a familiar path, a familiar trajectory, for example, from the subway station to their office at MIT, and they see things superimposed visually onto their experience of reality that are the subsequent winners of the Super Bowl. So you come out, I think I have them here, you come out of the subway at Kendall Square and you see a virtual guy with boxes, which will remind you that in the first year, 67, the Packers won the World Cup. Or whatever it's called, World Cup? Super Bowl, sorry, I'm not a sports fan. But then in 68, again, you see another guy as you go up the escalator with boxes, the Packers. Then you come out of the subway and you see a jet parked right there in Kendall Square, which reminds you that the Jets won the following year, etc. And it turns out that people that experience this once, they actually remember, other than remembering, in my case, whether it's Super Bowl or whatever, they remember I can tell you the subsequent winners because I can just retrace the path from the subway to the office and remember, oh yeah, that's where I saw a jet, and that's where I saw an Indian, etc. And so it's a trick that we can use to help people with learning and memorization. We've done other tricks like using, again, augmented reality to do language learning. In one system, you will learn a word in another language. I'm showing it in English, but based on your behavior. I'm not suggesting that that is what I spend my time doing, but so whenever you do an action, the system tells you in the language that you want to learn, like drink, drink, pour, pour, stab, stab, etc. And it turns out that people who learn things this way, who learn language this way, remember it much better because their whole body is involved in learning these new words, and they forget basically the words less than a control group who learns things without engaging in the activity. We've worked on supporting creativity. I'll actually go to this first. Some of you may know about the steel ball technique, which Edison, amazing guy, inventor, used very regularly, but also people like Dali, Tesla, etc., Einstein, they all use this. I bet you all will go use it, try it tonight, but basically what he would do was, when he had a problem that he couldn't quite get a good solution or think of a good solution for, he would sleep with, or try to nap with a steel ball in his hand, and the moment that his muscle tone relaxes, the ball, of course, drops. And at that moment, your brain is actually in a slightly different state where your executive functioning is less active. And your executive functioning sort of nixes a lot of good ideas that may come up in your brain. So he knew that he could actually do more divergent thinking when he was basically in that state where he just had fallen asleep, and would force himself at that time to think about the problem that he was trying to solve. And so others have used that technique successfully as well. So we built a device that makes that a lot easier to do. It just consists of a glove that based on muscle tone, based on heart rate, based on electrodermal activity, determines when you're about to enter stage N2 of sleep, which is when those, when that particular, you're not quite asleep yet, and you can actually talk, but you don't make as much sense as you do when you're completely awake. So at that moment, a system starts talking to you. We have a cell phone version of it at this point. So your cell phone starts talking to you when you're in that drowsy state, reminding you to think about the problem that you want to think about. And it records everything you say and tries to engage you in conversation while you're in that drowsy state to help you use your more sort of divergent thinking mind to think of solutions to your problem. We have actually been collecting a lot of data. Oh, this is a visualization that we did. Of some of the things that we collected, some of the dream reports that we collected that the BBC did for us, actually. But we did tests with this to see whether people do indeed talk and start thinking about the prompt that we give them. And we are also now doing tests to see whether it influences their deeper dreaming, basically, or their dreaming in REM that happens later in the night. Basically, people who were going through this, again, we gave them particular creativity tests, the alternative users task, for those of you that know that showed that people who actually were in this state came up with more suggestions and more ideas for uses of a particular object, a fork or a rabbit, than people in a control group. We're doing a lot on supporting mood and well-being as well. There's a lot of evidence that your affects may actually partially come from your body, and your brain interprets how your body responds to certain situations. So we actually built a device that gives you your own breathing rate is amplified in your ear, or breathing sound is actually played back in your ear, and we can speed it up or slow it down. And we did a test where we gave people basically the GRE test, and for some people we gave them a slower breathing sound than their own breathing, and for other people we gave them a faster breathing sound than their own breathing. And people, based on this self-perception, they basically report different anxiety levels. So people who have the sort of higher breathing rates report being more anxious than other people. We have some other results as well, but we didn't report these in our paper, but on people finding other people attractive based on whether you give them this feedback or not. Currently, we're doing some experiments with a similar idea. You may all have experienced chills, these shivers sort of running down your spine when you appreciate some beautiful music, or there's a piece of art, or it happens sometimes when you have a communal experience, like everybody singing a song together, etc. And we're seeing whether if we induce chills, will that actually give people or increase their aesthetic experience of the moment, and will it increase also their empathy towards other people when we give them this fake shivers or fake chills at a particular moment. So we're experimenting with all sorts of systems of this sort that basically try to seamlessly support some cognitive function to help a user become the person they want to be. I should say that this idea, or I want to make a note about AI, sort of. There's, of course, a lot of talk about AI in the news today, and mostly the sort of vision of human-computer interaction that the majority of people are working towards is one where we will have these independent, intelligent robots that actually kind of look like us, and they will help us, they will assist us with our function, with whatever needs to be done. But I actually don't like this vision all that much for a variety of reasons. Communicating with requires a user's complete focus. Language is not very specific, it's super slow. I want some kind of enhancement that is a lot faster and that is a part of me, rather than this separate entity that one day may want its own rights and may want me to say please and thank you, etc., when I ask it something. So the vision that I've been trying to pursue is that of, say, Tony Stark and other superheroes, basically, of the augmented human, of humans and machines becoming more integrated, actually, rather than separate entities that use language to talk to one another. And of course, that is not a new idea, and a lot of it originated here at MIT with people like Licklider, also Manfred Kleins talked about these ideas, Doug Engelbart, and so on. But I think it's a little bit of a forgotten alternative vision for where we would go or where we could go with artificial intelligence and with sort of how we interact with devices. I want to add a last slide that in all of our work, I mean, while of course we're pursuing positive applications, all of this could be used in very negative ways as well. The devices that we build track your brainwave activity, your eye gaze, your heart rate, your electrodermal activity. They influence all of that and intervene, etc. So it's, of course, there's a lot of potential abuses of these types of technologies, and we try to be aware of this when we develop these systems. Often there are technical choices that you can make that make it more or less likely that things can be abused, protecting the user's privacy, minimizing disruptions by the device, making sure the user understands what the system is doing and has complete control over it, avoiding dependency, and so on. So I'll end there. And I look forward to answering some questions if we have time. Thank you. Yeah.
Thanks, Pattie.
I guess we have 3 minutes.
There are some questions that come in from the audience.
Yep.
We have a few minutes, so we'll get to
Yep.
one or two, I hope, before Max starts. The questions, by the way, are mediated digitally by sli.do in case anybody wants to ask a question. That's the way we're doing it. You have to be connected, right? We're already looking at augmented people. You have to be augmented to ask a question. We may change the rule as the day goes on. Here's one question, and that I think comes from a student here. If we all augment our brains with these devices to improve our cognition and memory, will standardized tests and measures of intelligence become obsolete?
Interesting. I think a very interesting question that I think we can already raise today is, given that we are cyborgs already, all of you have a phone on you, probably a laptop as well, you can either sort of answer questions of your or your wetware, have your own brain answer a question, or you could go to one of these devices to have a particular question answered. And I think a big question that we will have to discuss and solve in terms of education is which things should people still be able to answer, and for which types of questions and knowledge and so on, is it okay to maybe delegate a question to a machine that you have at your fingertips or even more closely connected to you? There's clearly implications, or they're not the same. If you know something internally, you can make connections with other knowledge, with new experiences, etc. So we have to really think carefully for, say, for example, a doctor and how they are being educated and trained. Which things should they learn themselves, and which things can they look up on devices in the moment when they need to know it. Yep. It's a hard question.
There are a lot of questions coming in about the ethics of all of this. I even have
Yep.
one or two myself, but I'll probably save that for the panel. Question that's very particular, and since we play with this stuff a bit too, it's on my mind as well. How do you use EEG to measure attention, and how well does it work?
Yeah. How do you, well, I should ask Natalia, who's here in the audience, to answer it, but basically attention has been studied, and EEG, basically or formulas for reading attention from EEG have been studied for a very long time, as well as from EOG, or eye movements basically, and how they correlate to engagement is usually the term that is used more in the literature. So there's actually, we're not really innovating in that area. We're using standard measures that people have reported, but we're using them in a real world, sort of in the moment system to give this real-time feedback to people.
And we still have a ways to go before it's a foolproof measure, too. It's one of
Yep.
many variables
Yeah.
we can use.
The good thing is that random feedback is also effective to some extent. So if we get, it's not one of those things where you have to get it totally right for it to be effective and make a difference.
So thanks, Patty. Let's transition on to Max.
Yep.
So Max Tademark